March 2nd, 2011. We're going to do a little review of our quiz. You guys needed to define equilateral triangles, scalene and isosceles. All those types of triangles you need to know for your quiz and what a parallelogram is. You also need to have the definition of bisect. Make sure you looked it up. It's in the back of your textbook, okay? We're going to take up some questions from a couple days before. Page 77, 1A. So open up your textbook, page 77. They've given us a line, and it says to estimate the length of each line segment from this graph. I'm not too worried about the estimate right now. Then calculate the exact length, okay? So point A is at 2 and 1. So it's a little off. Here's our A, 2 and 1. So there's our point A. And our point B is at 3 and 5. Right here. Oh, geez, it is a little off. B, 3 and 5. Okay, let's get our line going. Oh, gosh. Okay, so we have our line. They've told us to estimate. One way to estimate it, guys, if you take a look, if we look horizontally, this line only moves about 1 unit, okay? So what that means is in comparison to a straight line, we'll do it in, let's say green, a straight line up and down. Straight line up and down from looking at this is, even though the arrow is a little high, 1, 2, 3, 4. It's about 4 units long, a straight line. So if this one's on a bit of an angle, we can estimate that it's going to be a little larger than 4, the length of it. Maybe 5, maybe 6, maybe 4.5. It's going to be larger than 4. We just don't know exactly yet. So as an estimate, if you'd said some number close to but a bit larger than 4, that's a great estimate. 4.5, anything like that works. Okay? Whoa. There we go. Okay, from there, okay, so now we need to find the distance of this line segment. Remember we had our 2 formulas. One was our distance formula, which is d is equal to the root of x2 minus x1 squared plus y2 minus y1, oh come on and fit, squared. Okay, that was our distance formula. If you guys remember, it was really similar to our Pythagorean theorem formula when we just rearrange it to equal c. C is equal to the root of a squared plus b squared. So I'm going to do this using Pythagorean just because it's quick. It's already graphed for us, so I can make a right angle triangle very quickly. Do our line. Our first part here, I do not want a green line. There you go. First point here goes 1 unit across. So the base of this triangle is 1 unit. When we go up, it is 4 units up. So we know the base. I'm going to write it over here. Base, 1 unit, and the height is 4 units. So what that's going to be, in a right angle triangle, our C is the hypotenuse of this triangle. So that's our line segment. We set it up so that would be the line segment. Our base is 1, so we'll call that the A in Pythagorean theorem formula. And we'll call B 4. So when we go to plug these in, we'll call this our A. And we're going to call this our B. Okay? We're going to plug those numbers into that formula. So we'll do it right on the side here. C is equal to the root of 1 squared plus 4 squared. Is that right? Yep. 1 plus 16. C equals the root of 17. C equals okay, apparently it is 4.12 roughly. So the length of this line, just like we estimated, is a little larger than 4. 4.12, we'll put this all here. 4.12 is the length of that line segment. Okay. So for your quiz tomorrow, I want you guys to try this question right now. Your blue notebook. Okay, this is question number 2 on page 122 in your blue notebook. They've given us a triangle. These are the points on the triangle. So, A, all it asks us is to draw the triangle. Pretty straightforward. Plot the points, connect the dots, just like junior kindergarten. So go 2. If you didn't know how to do it, I'll move you classes, don't worry. Okay. B is -1 and 3, even though I drew it very poorly. Sorry, Jeffrey. And C is 4 and 2. So, I have all my points. Connect the dots. A is already complete. Pretty straightforward. B asks us to use analytical geometry to verify that angle A. So, I don't have to solve for one angle. That makes the work a lot less for me. Angle A is a right angle. So, that means this is my A right here. Here's the angle. I need to verify that that angle is a right angle. So all I have to do is solve for the slope of AC and the slope of BA. Once I have the slope of those two lines, if they are negative reciprocals, which means they're perpendicular, then corner A or angle A is going to be 90 degrees. If they're anything else, it's not 90 degrees. Okay? So, luckily they've given us coordinates, so we're going to use our D formula to solve this. Remember that, let's try to organize this, a little. So, AC and BA. So we'll call this BA and line segment AC. So we're going to solve them left and right of each other. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay? So there's one of them. Same distance formula here. D is equal to x2 minus x1 squared plus y2 minus y1 squared, all under the square root. I'm going to write the coordinates of BA and AC right here, so it's very easy to plug these in. So, A is 2 and 5.
So do you want me to read it out?
Sure. A is 2 and 5, and A is in both of them.
And B is -1 and 3.
B is -1 and 3.
And you want C too?
Yes.
4 and 2.
C is 4 and 2. So I have all my points. Let's try to organize this so it's easy to plug in. In our first example, we're going to call A our 1s. So this is x1, y1. And we'll call our B our 2s, x2, y2. So that when we go to plug these in, D is equal to the root of, we know that x2 is -1, subtract x1 is 2 squared, plus y2 is 3, subtract y1 is 5 squared. Let's keep going. Distance is equal to, -1 subtract 2 is -3. 3 subtract 5 is -2. -3 squared is 9. -2 squared is 4. Root of 13. So I'm glad you guys noticed the mistake. I'm solving for part C right now. We're just going to continue. Now, I have d is equal to root 13. I can use my calculator and get a decimal, but root 13 is actually very exact. Since I just have to find out if they're the same, if I look at the length of the other line segment, if it is also root 13, then we know it's going to be the same. If it's root of any other number, it won't be the same, and it'll help us classify this triangle. So let's go back up. We don't have to go any farther than what we had. A will do our 1 again, and C will be our 2. So x1, y1, x2, y2. D equals x2 is 4. Subtract x1 is 2. Squared plus y2 is 2. Y1 is 5. D is equal to the root of 2 squared plus negative 3 squared. D equals root 4 plus 9. D equals root 13. So, we've already solved for 2 of the lines, and we know they're equal. So it's definitely not a scalene triangle. It's at minimum an isosceles. We're going to have to find the other line segment. If the other line segment is the same length, then it's an equilateral. If it's not, it's isosceles. So we've got to find our final one, which will be BC. Let's do our final one here. Line segment BC. Write the formula again. Whoops, pushed the wrong button. Okay, gonna have to move quick because we gotta do this in under 15 minutes. So, let's get this half done. I know that point C is 4 and 2. And point B is negative 1 and 3. Do the same stuff we did above. I'll call B1, C2, so x1, y1, x2, y2. Then plug them in. D is equal to the root of x2 is 4. Subtract negative 1. Make sure we get that. Get an extra bracket there. Y2 is 2. Subtract y1 is 3. Squared. D is equal to the root of 4 minus negative 1 is 5. Plus negative 1 squared. Already I'm starting to notice that this is not going to be the same size. D equals the root of 26. So,
5.09.
okay, but we actually don't have to go any farther. These are our lengths of the lines, or the line segments, sorry. 2 are the same, 1 is different. What type of triangle do I have? It's an isosceles. Ramel, spell it for me.
Pardon?
Spell it for me.
ISOSCLES. I spelled that wrong.
We have an isosceles.
Which are the 2 that are the same?
So, that's what we needed to do to classify that triangle. It's all covered up for us. We discovered 2 sides were the same, 1 was different. Oh, I keep pushing the wrong button. Sorry, guys.